so they catch around a bar. It should have been totally reliable, but it was not.
The design fault was this. You could actually operate the lever and it felt as if it had locked, but it could have failed to lock completely.
Investigators find that the door lever could appear to be properly closed, even though the locking claws were not being held in place. It's a clear example of engineering error. The investigators start to piece together an horrific chain of events. It all starts with the door's failing locking mechanism.
Basically, they were doomed from that moment on, because when the cargo door blew out, all of the air in the cargo hold beneath the cabin floor exited this very, very large hole.
The blowing out of the cargo door was the first disaster. Then the pressurized air in the cabin also tries to escape to the outside, smashing a hole in the cabin floor. It's this violent rush of air which sweeps 6 passengers out of the plane to their deaths. Those were the 6 people found 10 miles from the main crash site, still strapped to their seats. The collapsing cabin floor leads to a further disaster. It destroys vital control cables.
Hydraulics? We've lost it!
These cables work with hydraulic pressure to move critical parts, like the rudder and stabilizers. Without them, the pilots are unable to fly the plane.
I can bring it up. She's not responding.
So the pilots had no control over the airplane any longer. They literally couldn't tell the airplane any longer what to do.
Years later, in memory of all those who died, Bruno wants to find out the full story behind the crash that killed his father. From all the available evidence, it's clear to him that this wasn't an accident. It was caused by engineering error.
For me, this tragedy is not an accident. Accident, it's bad luck. Here we are in...
It is the worst single aviation accident in US history. There are now 2 big questions. Why had the engine fallen off? And why had a plane designed to fly on just 2 engines flipped over out of control? Answering why the DC-10's engine fell off proves alarmingly simple. It's a case of poor maintenance. One of the attachments holding the engines in place had been cracked, and no one had noticed. Urgent checks reveal similar cracks in 6 other DC-10s. The concern is the entire fleet in America is now at risk. That's a frightening 138 aircraft.
I have no choice but to ground all US DC-10s immediately.
The blame for the cracks falls on the airlines, not on the plane's manufacturers, McDonnell Douglas. But then the investigators discover another critical error. And that error has to do with fail-safe design. The idea that if there's a catastrophic failure, the pilot should still be able to control the plane. It all goes back to the moment when the plane banks to the left. That happens because the engine coming off ruptures vital hydraulic control lines, operating slats on the wings.
When the engine tore itself away from the wing, it destroyed the hydraulic system which kept those slats extended. When the slats retracted because they had no longer hydraulic pressure to keep them out, that wing lost lift.
Just like in the Turkish Airlines incident, the plane crashes because pilots lose control. The lesson of fail-safe construction has not been learned.
That is not in the best traditions of aircraft design. Aircraft design is supposed to be based on what they call fail-safe. If it fails, the aircraft's still safe. This broke every rule in the book.
Over the next few years, the DC-10's engineers do learn this lesson. They install mechanical systems to make the DC-10 safe. But they can't patch up the plane's damaged reputation. Today's DC-10s are mainly used as cargo planes. It is Boeing's 747 Jumbo that becomes the world's most successful passenger jet. Its engineers seem to have learned the lessons of fail-safe design. Until that July evening in 1996, when TWA Flight 800 blows up, killing all 230 passengers and crew. After months of painstaking work, the crash investigators have reassembled entire sections of the shattered plane. Once they'd ruled out the possibility of a missile or a bomb, they search for the source of the explosion in the plane itself. Eventually, they find it. The central fuel tank has blown up. So what had done it? It didn't take long to identify the culprit. It was right there in the tank. Fuel vapor. When Boeing's engineers designed the 747 in the 1960s, the plane was expected to fly with all its tanks full. But when fuel prices rose, the airlines had to cut their costs. Christine Negroni has written extensively about TWA 800.
As we started to get more concerned about our use of fuel in the 70s and the 80s, airplanes stopped flying with full fuel tanks. If they didn't need the fuel, the tank went empty.
But investigators discovered that flying with empty fuel tanks posed a risk that had not been fully recognized. On that July afternoon, TWA 800 is sitting out in the baking heat at JFK Airport. To keep costs down, its central tank has just a puddle of fuel in it. And when that fuel gets hot, it turns into explosive vapor. This situation is made far worse by a second engineering error. Directly beneath the fuel tank, Boeing's engineers have put the plane's air handling units. These provide filtered air into the passenger cabin. But while they're making the passengers comfortable, these units are also giving off heat. And that heat is going straight into the fuel tank. The investigators now uncover a terrifying scenario. TWA 800 is climbing away from New York with a highly explosive fuel tank. The 230 people on board have no idea. It's like sitting above a bomb waiting to detonate. All it needs is a spark to set it off. But that's a risk Boeing's engineers thought they had eliminated. Their fail-safe design should have prevented it. They had made sure the only wiring allowed in the tank used a very low voltage. Not enough to cause the spark. Bob Swaim is a key member of the investigation team. He begins his hunt for the cause of the spark by taking another look at the cockpit voice recorder.
We came to realize that some of the background noise dropped out. Well, the energy didn't just disappear. It went somewhere.
Where the energy went was a short circuit, somewhere in the plane's wiring. And short circuits can cause sparks. But Bob Swaim's still puzzled. There's only low voltage wiring in the fuel tank. Even a short circuit shouldn't have been powerful enough to create the deadly spark. Looking for an explanation, Swaim and his team sift through the vast extent of the plane's wiring.
We examined 150 miles of wire from this one airplane, inch by inch.
What they find is some of that wiring is in a terrible state. And many different wires with cracked insulation are bundled together.
And this was really important because you could have wires that were powering electric lights with over 150 volts laying next to wires that would go to a fuel tank, which should never have more than 5 volts.
Swaim now realizes if the high voltage wiring is damaged, a dangerously high current could jump across into the tank's electrical system, causing the fatal spark. The investigation finally pieces together the sequence of engineering errors that brought down TWA 800. First, fuel vapor builds up in the tank. It's heated to a critical state by the air handling units. Cracked wires allow high voltage current into the tank. There's a short circuit, a spark, and the tragic result